The next reaction is the reaction with acid. The reaction with acids. You know what is an acid? What's a base? Hydrochloric acid, acetic acid, citric acid. And base are sodium hydroxide, etc. Okay, which we use it in soap and all, it is bases or alkali. You have studied it in your lower classes. Acids means what? Which is present in the fruits, in lemon, in vinegar. The acid is present. Okay, so whenever any metal which is reacting with acids, what we will get is, we will get salt plus hydrogen. Hydrogen gas will be evolved plus salt is formed. Salt, what is salt? There are different types of salt, but the salt which we are familiarized is sodium chloride, which we use in for the cooking purposes, sodium chloride. So how it is formed, I'll explain it. Metal sodium, this is an highly reactive metal, plus acid, hydrochloric acid, HCl, hydrochloric acid. Cl means chlorine, H means hydrogen. When it is combined with chlorine, it will form a hydrochloric acid. Okay, sodium reacting with acid, we will get sodium chloride plus hydrogen gas. Very important. This sodium chloride is salt. Clear? This sodium chloride is salt. So sodium reacting with hydrochloric acid, it will form sodium chloride plus H2 gas. Okay. So then one more example, aluminium plus HCl gives AlCl3, aluminium chloride plus H2 gas. This is another salt, aluminium chloride is another salt. Okay, one more example if you want, zinc plus HCl gives ZnCl2 plus H2, zinc chloride. So don't worry about these things, these equations and all, you will study how to write it, why it is written like this, how they are combining together. These things and all you will be studying in detail. The whole theory you will be studying it in your higher classes. Don't worry about it. Now you just understand which are the types of reactions happening in the case of metals. So when the metal is reacting with acids, what will be formed? Acids will react with metals to form salt and water. I hope that's also clear to you. Okay, so these are the metals, the main important reactions of metals. And one more reaction, it is reaction of metals with metal solutions. Reaction of metals with metal solutions. Okay. So what will happen is, in the metal solution there will be a metal present, and whichever metal we are putting it into the metal solution, if they are more stronger, whoever it is more stronger, they will be replacing the other metal. For example, let us just consider this case. Fe, ferrous iron plus copper sulfate. This is metal, copper metal is dissolved in sulfuric acid, we will get copper sulfate solution, copper sulfate. So if iron is dissolved in iron and copper solution, this can be called as copper solution, COPPER, copper solution. So copper is a metal. So here what I will say is, this iron is more stronger than copper. Iron is more stronger than copper. Whenever you are sitting in a bench, if 3 of you are sitting, and out of the 3, one is a weak one and he is sitting to the side of the bench, and whenever a stronger person comes and he wants to sit in that bench, what he will do? He will push that person, he will push from the other end so that the weaker person will be thrown away and he will be occupying his seat. So the stronger one will displace or replace the weaker one. Okay, here what I will say is, this iron is stronger than copper. So copper is weaker one. So what the iron can do? Iron, Fe, ferrous iron, what the iron can do? The metal iron can displace copper from this solution and it can form its metal solution because it's stronger. Okay, that means the stronger, weaker, etc. What we will say is the reactivity of iron, the strength, reactivity, how much strength it has to react. The reactivity of iron is more than that of copper. The reactivity of iron is more than that of copper. So what it will do, it will displace copper from its solution and it will form its solution, and copper will be converted it into metal itself. It will be thrown away from the solution. So copper will remain as such as copper metal itself, and the solution will be turned into iron sulfate. And how we will understand this? How we will understand this? Like ferrous iron, this one, this copper sulfate solution, if I am taking it in a vessel, this will be blue in color. This will be blue in color. Okay, and when I am putting the iron, this is grey color. When I am putting the iron into this blue colored solution, after some time, the iron will be, this solution will be turned into green color. I hope you can see. This solution will be turned into green color. The blue colored solution, after the immersion of this iron metal into this solution, the blue color fades and the green color appears. So this green color solution is characterized by the presence of iron sulfate. Ferrous sulfate solution, iron sulfate or ferrous sulfate solution is green in color, we know it. So whenever it is converted into green in color, we can understand that the copper is being changed, and we will see some granules over here, some deposits over here, that is what copper. So from this color change we can easily identify the iron which is more reactive or more stronger displaced the weaker copper iron from the copper sulfate solution and it made ferrous sulfate solution. I hope it's clear. Okay, so whenever metal is reacting with metal solutions, the higher reactive metal will displace the lower reactive metal from its metal solutions. Okay, and we will discuss the reactivity order of metals, which is the more reactive one, which is the lower reactive one. We will discuss it in the next class. Don't worry about it. So, but now listen, understand it that whichever metal is stronger, they will displace the lower reactive ones or weaker ones from the metal solutions. That's clear? Okay, so this example you can note it down. If you want, I will give you one more example. Zinc plus copper sulfate gives ZnSO4 plus copper. Zinc will displace copper sulfate from zinc. Zinc will display copper from copper sulfate and it becomes zinc sulfate. Clear? So these are the examples and these are the reactions of metals. What are they? Reaction of metal with oxygen, with water. Then what it will do? It will react with acids and also it will react with metal solutions. Metals will react with metal solutions and they will displace the weaker ones from the metal solution and the stronger one will occupy the space of the metals. Okay, so I hope it's clear to you. Okay, so now we will be continuing the discussion on the reactivity series of elements. Okay, the previous discussion I have told you that the metals, some metals are very stronger than the other metals. Okay, so the strength of the metals and the strength of the elements, etc., it's all depending upon a lot of factors. Okay, those factors you will be studying it in your higher classes, like elements, the atomic structure, the electrons, the arrangement of electrons, the stability of the atom, etc., etc. You will be studying it. So don't worry about that. Okay, so now what is the reactivity series of elements? That means I have told you some metals are more reactive, some metals are less reactive. So the reactivity means the strength of the element to undergo reaction. The strength of the element to undergo reaction. Okay. So according to their strengths, we have the scientists or the chemists have done a lot of experiments on various reactivities of the reactions of each element, with water, with oxygen, with acids, etc. And from that they have tabulated a list of elements. They have tabulated a list of elements. Okay, like the topmost position is given to the most reactive, the last the position is given to the less reactive elements. Clear? Okay. So, according to the reactivity series means the decreasing order of the reactivity of elements, arrangement of elements in the decreasing order of reactivity or the strength of the elements to undergo reaction. Okay, the first element, the most reactive element in the universe is potassium. Next one it is sodium, then calcium, magnesium, aluminum, zinc, iron, lead. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead. These comes under metals, and below that the next reactivity after lead, the next reactivity element is hydrogen, non-metal, copper, mercury, silver and gold. So, gold, mercury, silver and gold, they are the least reactive elements. That means whenever the gold is present in the pure form in the earth's crust, when we are mining the gold is obtained in the pure form itself. It won't react with any other element. It is least reactive. They will be present as the pure gold itself in the earth's crust. Okay, but this sodium, potassium, etc., they are highly reactive in such a way that if we keep it in open air, it will catch fire, it will burn, it will start to burn, this potassium and sodium. That's highly reactive. Okay, so this reactivity order is based upon a lot of factors. Okay, but you have to understand, you have to study this order should be there in your mind. So, from this order we can understand whether which one will eliminate the less reactive ones from the metal solution, etc., which we have discussed the last portion. Okay, and one small tip in order to study easily the first five elements, it is potassium, it is denoted by the letter K, in Malayalam it is Ka. Then sodium, it is denoted by the letter Na, that is Na. Okay, then Ca again Ka, Mg it is Maga, and Al it is L. So, in order to study, in order to by heart the first five, potassium, sodium, calcium, magnesium, aluminum, Kanagamagal, just note down this small tip so that the first five reactive elements won't be forgotten by you. At any time you will be knowing it. You just remember this tip so that you will understand that these are the first five reactive elements, and the least three are mercury, silver and gold. Okay, so this is the reactivity series of elements. Clear? Okay, have you noted down? Clear. Now, as we have discussed the reaction of metals, we will have to discuss the reactions of non-metals. And as is the case of the non-metal, when it is reacting with oxygen, it will give non-metal oxides. Non-metals, as in the case before, it was metal reacting with oxygen to give metal oxides. Now, non-metal reacting with oxygen, it will give what? Non-metal oxides. Okay, an example, sulfur, when it is reacting with oxygen, we will get sulfur dioxide. Carbon, when it is reacting with oxygen, we will get carbon dioxide. It is a non-metal oxide, carbon dioxide. Clear? And the next two, reaction with water and reaction with acids. Usually, non-metals won't react with water and acids. Usually, there are some exceptions, but you noted down that usually the non-metals won't react with water as well as acids.